The first one, we have the vector u plus the vector v equals the vector v plus the vector u. And this is what's known as the commutative property of addition. And we could prove this. We have the vector u is u1, u2. Vector v is v1, v2. So u plus v is u1 plus v1, comma u2 plus v2. On the other hand, we have v plus u is v1 plus u1, v2 plus u2. And since we know that u and v are real numbers, and in real numbers, addition is commutative, then these two are equal. Alright, so our next property is the associative property of addition. So that says that we have the vector u plus v in parentheses, and we add that to the vector w. That's the same as u plus the vector v plus w. So this says that we can group vectors to add any way we like. Third, we have an additive identity. So that is that to any vector v, we can add the 0 vector and get back the vector v. Because we know that if we have a vector v1, v2, and we add the vector 0, 0, we're going to get the vector v1, v2. Our next property is the additive inverse. This says if we have a vector and we add the vector going in the opposite direction, so it has the same magnitude but it's going in the opposite direction, that this equals the 0 vector. Next, we have the distributive property where we have a scalar multiplied by two vectors added together, and that says that we can bring the scalar inside, and that's c times the vector u plus c times the vector v. On the other hand, if we have two scalars being added together, so scalars a and c, and we multiply them by a vector v, that's the same as a times the vector v plus c times the vector v. Next, we have multiplication by a 0 scalar. So if we take a vector, we multiply it times the scalar 0, then we get the 0 vector. So if we have 0 times the vector v1, v2, that's 0 times v1, 0 times v2, which gives us 0, 0, which is a 0 vector. Next, if we take a scalar and we multiply it by the 0 vector, we get the 0 vector. So if we take 6 and multiply it by the 0 vector, we get 0. We get 0, 0. Next, we have the multiplicative identity. That is, if we take 1, the scalar 1, and multiply it times the vector, we get our vector. And finally, we have the associative property of scalar multiplication. It says we take one scalar and multiply it by the quantity of scalar times the vector. That is the same as multiplying the scalars together first and then multiplying it by the